have questions on?
Wasting. I did it wrong.
So I see a lot of 3s and 4s and 1s as majority, so we'll do those 3. Okay, so 1 can be done in Desmos. So you could do this one of 2 ways, either put 2/3 in for all the x's in parentheses, or put in the equation with capital X's, add in the slider, or change the variable. So I'm just going to put it in using parentheses. And it would give us repeating 0.4s or 4/9. And then if you use the slider, you should get the same thing. If you're just putting 4/9, make sure you use Desmos. Questions on that one? Okay. Number 3, we are looking for, we know this is the total for 12 gallons, and we need to know how much does 19 cost. So if I had some variable x that would represent the price. Probably going to be hard. It's either each or 19. And because of what's given, we could set this up as a proportion. 2493, you know, is the total. Whether you put this in the numerator or denominator, it doesn't really matter. You just have to do the same thing on the other side. So this total we know is for 12. We are looking for the total for 19. And then we could either put this into Desmos or solve it by hand. If we solve it by hand, and then if we divided both sides by 12, x was
39.47
about $39.47. If you would put this into Desmos, I'll come back to that in 1 second. You'd have to zoom out to find it, but then it would show you that same thing. And you would round it since it's dollars.
Do we have $30 off the tax?
That's fine. You just need a unit of measurement. Questions on 3?
So, could you theoretically divide 24.93 by 12 so you can get the price per gallon, and then times that by 19 just to get your answer?
You could also do that.
Okay.
And then for number 4, the equation of the horizontal line. So horizontal line is going to be a y equals. Look at your y value, and this will be y equals 5. You could also put this into Desmos or graph it, it doesn't matter. And if it was a horizontal line, you'd have to find what this line would be, which would be y equals 5. If you did x equals 2, that would be a vertical line, and that would not be your answer. So you could have looked at the graph, you didn't need it. But your answer was y equals 5. Questions on that one? two things that I don't think I mentioned Monday, but if I did, it's a repeat. If I didn't, then here's information. For your SOL packets, if I didn't check them Monday, I'm no longer checking them, so the 0 that you have is just that 0. And then for the one that's due on Tuesday, make sure you do that, because I won't be checking that late either. So make sure you do all of 7E, not 8 and 9, that way you get that grade and it doesn't end up as a 0. The second thing, for your decimaths, remember that those are formatives, and as we're not quizzing Unit 8, 9, and 10, and they're formatives, I'm treating them like quiz grades, so if you don't attempt them, I'm not replacing the test with them. So make sure you are attempting them and doing them. Email me so I can update your grades if you are doing past ones. Questions on either of those things? Alright. Then today we're going to talk about still the first section of Unit 10, graphing, but now we're graphing exponential functions. So everyone should have notes that look like this. And we're really just going to talk about the basics of how to graph this, how to find it in the table, find the values and things like that. So in this, we're going to let A and B be real number constants, and this is an exponential function. Exponential functions are written in the form y equals a times b raised to the x power, where a does not equal 0, b is greater than 0 or it's positive, and b doesn't equal 1. Here are some different examples you might see. There are other examples as well, and we're going to go through some of these and graph. So in these beginning tables, I give you the x values, I give how that would look so we can find the y, but later you'll have to put in your x's and y's. So if I have these x values, -2 through 2, I'd be putting these in where x is, so this would be 3 to the -2, so our exponent rules come back. Our negative exponent rules tells us that 3 to the -2 would be what? Not -9. It wouldn't be negative at all. Positive? It would be positive, not just 9 though. Your negative exponent rule tells you to take the base and flip it, make the exponent positive, so it would be 1/9. So 3 to the -1 would be 1/3. Anything to the 0 is 1. Unless it's 0 or a negative. 3 to the first power? 3, and 3 squared. Nice. So go ahead and graph those points. The first two, just plot them to the best of your ability. They'll be small. So estimate it. Mine kind of look about the same place, but it's okay. Do you see it makes this curve like? You're going to draw arrows at both ends. But this one, don't let it cross the x-axis. I'm going to show you why in just a second.
Wait, do you have the whole thing or is negative?
Graph the whole thing, yes. And then what would the y-intercept of this graph be? 0, 1, right as ordered pair. We talked about domain Monday. That's your x values, looking at it left to right. So where would this start? If this keeps going to the left. Negative infinity. Where would it stop? Positive infinity. So just like our quadratics, our domain is going to be negative infinity to positive infinity, or x such that x is an element of all real numbers, just so you see that, get in the habit of seeing that. It doesn't change. Our range, however, is going to be a little different. So I'm going to tell you what it is, and then I'm going to show you in the graph what that will look like after we approximate. This looks like eventually it's going to cross the x-axis. In Algebra 2, you'll learn that there's an asymptote, invisible line that makes it not cross it, in place at or on the x-axis. So it's never actually going to cross the x-axis, just get really, really close to it. So it's going to actually start at 0, but not include it because it'll never touch it. And then the highest point,
9.
infinity. It goes past 9 towards the sky. And then the approximate part, we're going to do that in the calculator, but if you have to guess, 0.7 I know is between 0 and 1. So that would be somewhere here. If we had to guess, what do we think that point would be? The y value, what do you think that y value would be? Okay. Any other guesses?
2 and 2/3.
Okay. Okay. In your calculator, put 3 raised to the 0.07. Tell me what it actually is. So we were off, but that's okay. It was just a guessing game, just to see if you could. You know it would have to fall between 1 and 3, so these answers, this one was probably too much, but this answer wasn't a bad approximation. Okay. In the graph, I'm going to show you this on the calculator and on Desmos. I'm going to go into y equals and put in 3 to the x. And hit graph. Now, on the calculator, it looks like this is touching the x-axis. In your table, as I start to go back, I see that these numbers get really, really small. There's a bunch of zeros in our scientific notation. But on Desmos, I see it does look like it's on the x-axis, but as I zoom in, I see it's not actually touching it, it's just getting really, really close to it. And the further I go along, even when it looks like it's on the x-axis, it's not. And you could do that forever and ever, all the way to infinity, on your own time, and see that it would never actually touch the x-axis. Just get really, 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 really close to it. But that is the basics of how we graph an exponential function. Do you have any questions on that? Alright, let's do another. Let's do. We might have time to do 2 before lunchtime. With your exponential functions, you'll start to see a pattern. You can either individually find each of these, or in this case, my base was 3. So each time I'm multiplying this by 3. So there'll be some pattern you see that's getting exponentially bigger. So in this one, 7 to the negative second would be what? 1 over not 14, but 29. And then 7 to the negative 1, 1 over 7, 1 over 7, 7 to the 0, 1, 7 to the first, and 7 squared. So we obviously can't graph 249, but we can graph the other ones to the best of your ability.
I don't know how to do that.
Which one? Just make it really, really close to the x-axis. So it has that same curve, it's just a little steeper. Because of the base. So the y-intercept of this one, 0, 1 is the same. Domain, negative infinity, positive infinity, it hasn't changed. Our range, 0 to infinity, 0 to infinity.
It's
Yes.
always going to be 0 to infinity.
No. We're going to do some where that's not the case, but if we have just a whole number base, then it will be. And nothing else, then it will be. Anyone want to take a guess as to what 7 to the 0.05 would be? Okay. Anyone else want to take a guess? 1.2. Okay.
I have a guess.
2.7. Denver.
2.6.
2.6.
Hey, that's my guess.
3.6. Great.
0.9.
I have a more exact guess.
Now, the 0.9 probably won't work because it's not between 1 and 7, but the others might be more.
I have an exact.
You put it in the calculator.
No.
Okay. What is it?
I guess 2.645.
6.4. So nearest 10th would be 2.6. So some of us are close, some of us are a little off.
I was right on.
It's just a fun game. Hold on. We could start this next one. I don't know if we'll finish it. So now we have a base of 1/3. Negative exponent rule is still the same. Take the base, flip it, raise it to a positive 2. What would this be? 9. 1/3 to the negative 1. 3. 1/3 to the 0. What's the pattern? We're dividing by 3. So then 1/3 to the first should be 1/3. 1/3 squared should be 1/9. Graph those points. And you'll see that it switched directions. Y-intercept of that one is
I would say about 1.
0, 1. It can stay the same. Domain,
I would say about 0 to infinity.
it stayed the same even though it changed direction. And then we'll do the last two when we get back from lunch.
Oh, we could actually
What is the range of this one? So it's always lowest to highest. 0 to 0 to infinity. So even though it switched directions, it's still the same range. Do we want to guess what this might be for the approximation? Negative 1.5. Is that the exact or were you guessing? Anyone else want to take a guess before we find the actual? 5.2. That's great.
7.1. I'm going to go with 5.2.
Is that what it actually was? And we don't have to do this each time. You could just find it. It's just
Fun.
course. Fun to see if you could try to figure out, guess between the table, the graph, could you guess what the actual number is? Alright, we're gonna do number 4 and then skip around some. So another fraction base, 1/2 to the negative second would be what? 2. Negative 4. Not negative, but positive 4. 1/2 to the negative 1. 2. What's our pattern?
By 2.
Dividing by 2. So this should be 1 non-negatives dividing by 2, 1/2, and 1/4. Graph those 5 times.
Okay.
Do you see it makes that same curve towards the same direction as the last one? Y-intercept is still 0, 1, domain. Negative infinity to positive infinity. It has a change, range. 0 to infinity. So far, it's been the same. Do you want to take a guess as to what 1/2 to the negative 2.5 would be?
No.
I'm going to say like 5.9.
I'm going to agree with you. I'm not trust you.
Okay. I just looked at the graph. I don't know if it's actual. 2. For this one? I second 5 point. Okay. What is it actually?
5.7.
Okay. We're so close. Alright, we're not going to do 5, but let's do 6. So now we start to change our a value to different numbers and see how that affects our graph. So same as before, but we have a negative. So think about this as 1/5 to the negative second. Do that and then make it negative.
Yeah.
Negative 2.5. So negative 2.5. So 1/5 to the negative 2. Take it, flip it. It would be positive 5 to the second power, 25. Make it negative. Negative 5 to the negative 5. What's our pattern? We're dividing by 5. So negative 1/5 to the 0. 1. This would be negative 1. Because 1/5 to the 0 would be 1, but then multiply by negative plus 2. Negative 1/5 to the 1. Okay. And then the last one.
Negative 1/25. I did something.
So go ahead and graph those.
But I thought it wasn't allowed to be negative.
What's on?
The y.
The b value can be negative. A can be negative. So now it's flipped again. Let's see what that did to our characteristics. What is our y-intercept now?
0,
negative 1. Our domain.
negative infinity to infinity.
Okay, so domain did not change. What about the range?
0 to infinity. Infinity to 0.
Negative infinity to 0. So that part switched. For y, such that y is less than 0. So when you have a negative a value, your y-intercept becomes negative, and your range is now underneath the x-axis instead of above it. Do we want to guess what this would be?
We should. It's a fun exercise. There's some guesses out there.
So at negative 0.5, I'm going to say it's between negative 1 and negative 5.
Oh, I did not do
Negative
that.
4.2. Okay, I'm going to say negative 3. Negative 2.9.
Something around there, maybe. What did you say?
Negative 2.2. Is that what it actually was? Questions on that one? Let's do 6. I'm sorry, 7.
Not similar, but we have another negative, but our base number is whole.
And we don't have parentheses. So whatever the numbers here are going to be negative. So negative 5 to the negative second. It is going to be negative, but 1 over 25.
Yeah.
Okay. Negative 5 to the negative 1. Negative 1/5. And then negative 1. Keep going. Negative 5 and now if that was in parentheses, the negative was with it, then that'd be positive, but in this case it's not. So then graph those. Oh, I definitely just graph those on. Okay.
That's okay, me too.
Y-intercept of this one? Still 0, negative 1. Domain. Negative, positive. So that hasn't changed. Range. Negative, so if you have a negative and nothing else is there, then domain doesn't change the y-intercept. As long as nothing else is there, we're just going to make it negative. The range is just below. We'll guess on another one. Go ahead and put this in your calculator. Find what that is. Negative 2.8. Okay, now we're going to try 8. Yes.
Is the y-intercept always have to be 1 or negative 1?
No. That's what we're about to see.
So you basically tell us the next one is
Correct. It depends on what the function looks like, really. But it also depends on what's being multiplied out here. Because that will really tell you what it is. If nothing else is happening. So think about this as just 1/4 to the negative 2 and then multiply it by 3. What would that give us?
0.
What did you say? 1/4 to the negative 2 would be 4 squared.
16.
Times 3.
No. 48.
You see that quick math? So 1, and then 1/4 to the negative 1 times 3. 12. 1/4 to the 0 times 3. 3. Divided by what? 4. So then the next one would be,
How come that one belongs to the 0 power isn't 1?
so this one is, 1/4 to the 0 is 1, but then when I multiply it by 3, it becomes 3.
Oh, okay. 0 y-intercept is 3.
Yes.
Okay.
0, 3. But 3 times 1/4 to the 1 power. First power. 3/4. And the last one. 3/16. We were dividing by 4 each time. So y-intercept is 0, 3. if I look at my A value, that'll tell me what that is. And then go ahead and graph those. The negative 112, you can kind of graph off the graph. Right there. Mine looks like it's running into the x-axis, but it's just getting close to it. Did the domain change? No. It's the same. Negative infinity to infinity. What about the range? No. Yes. Change from the last problem, but it's still one of the ones we've done. What is the lowest? 0. And highest? Infinity. If we were to guess this, 0.5 is like there, so maybe 1.5-ish. Make sure you're using parentheses when you do that one also. What did you get? 1.5. Nine's going to work similarly, so we're going to move on to 10. So now we are not only just multiplying, we're changing the a value to multiply, but also it's negative. So let's see what happens there. So do 9 to the negative second power first, and then multiply it by negative 3. Negative 3 over 81, does that simplify into what?
Like a fraction?
This is going to be 27. 127 over 27. Yep. 9 to the what? 9 to the negative 1 times negative 3.
1/9.
Times 3. Times negative 3.
Negative 1/9.
Negative 3 over 9, which would simplify to 1/3. 1/3. Oh, that should be negative. Negative 1/3, yeah.
Multiply.
Negative 3 times 9 to the 0.
Negative 3.
Negative 3 times 9 to the first.
Good. Tell you.
Negative 27. And negative 3 times 9 squared. Negative 3. Nope. 81. Negative 81. Times negative 3. It's positive 81. Sorry, times negative 3.
81 times negative 3.
243.
Yes, but it's not.
Yo.
So, obviously we can't graph a lot of these, but try to graph the first 3. You could extend the graph a bunch shorter.
So basically, I need to be put in the hospital because all that math is made attack.
Let's see.
Oh.
You okay?
I think so.
No, she had a heart attack. You haven't heard that part. Of course she's not okay.
What is our y-intercept?
Negative 3.
Yeah. So again, whatever that a value was our y-intercept. Did the domain change?
No. Yes. No.
No, not in this one. The range is what?
0 to positive negative infinity 0.
Okay. Negative infinity to 0.
50 shot.
Go ahead and put that in the calculator. Approximate that.
Negative 1.
Was that the actual answer?
Yeah. C.
That was 10.
Alright, we're gonna skip a few pages. Find 15.
Question 15 or page 15?
Question 15.
Okay. What are you doing option?
Pretend you don't see any of that.
You just brought my attention to it. I still missed it.
It looked for a second like there might have been, right?
There may have been.
It faded away though. How did that happen?
You
should show it again. You should show it again.
Okay.
Click undo.
For this one, you don't have any x's or y's.
Yeah.
So in the middle, you want your y-intercept regardless. And a good amount of numbers or a good set of numbers to have is just the ones we've been using, -1, -2, 1, and 2. And then you could either put each of these in and find them individually, use your calculator, or use your table. So if you wanted to do it individually or by hand, you're welcome to do that. In your calculator, if you wanted to do that, go into your y equals and put in that function.
Why is it the plus 3 to 1?
And then go into the table, second graph. It says 3, but it's actually getting close to 3. It's not actually. So then the y-intercept is 4.
Would never thought.
And then you can just put the decimals for those, so 3.0625. If you would put those in for x, 4 to the negative second would be 1/16 plus 3. Figure out what that is. 4 to the negative 1 would be 1/4 plus 3. 4 to the 0 is 1 plus 3. 4 to the first is 4 plus 3. And then 4 squared is 16 plus 3. So you can do it either way. And then graph those. What is the y-intercept of this one? 0, 4.
1 plus 3.
Did the domain change?
No.
No, it's still the same.
Negative infinity to infinity.
But what about the range? What's the lowest point?
That's so good question.
Look at where this is getting close to. What are these going down to get close to?
3.
It's getting closer to 3. So it starts at 3, and then the highest point,
Infinity.
so this changed our range. So if you add or subtract something, that would change where your range starts. In set builder notation, that would be everything greater than 3. And then there isn't an approximation for this one, but you could do that if you wanted to pick a decimal and approximate it. Questions on that before we do our last one, then you have time to practice.
No.
This one is the mortality one. Go to 60.
There's no breaks in class.
Sorry.
I'm not very good at this. I'm not doing this. You get to distribute.
No.
Okay.
That's not what I'm doing.
No, nothing.
Sorry, I like school.
Okay, no, but it's ridiculous. That is absolutely, utterly ridiculous that you got
Remember negative 243 off the tip of your head.
81 taking 8 times 3, 24.
That's
really
I
No, okay.
I have a lot of
Spin stuff.
Also,
Oh,
9 to the third power
Quality
is
Schools
243.
International.
Fill out your table. And then again, you could do this by hand, put each one in and figuring out what that is, or use your calculator, put that in and find the y values. Go ahead and do that. And tell me what you get.
Tell me to.
For 0, I got negative 7 halves.
Okay. So negative 7 halves or negative 3.5, either or.
Negative 1, I got negative 3.75. Negative 2, negative 3.875. 1, negative 3, and 2, negative 2.
So when we go to graph these, they're really close together. So if you want to include more points, I probably should have actually put this in here. What is it? 2 to the x. What was the rest of that? You could put in 3, 0 and 4, 4, 5, 12 if you want, just to have more points to graph. Don't have to do this, but just so you can kind of see that curve. 4, 4, 9. Or you could just make up what you think might be the curve. Either or, doesn't matter. The y-intercept of this one, 0 and negative 3.9. Did the domain change? No. No. Negative infinity to infinity.
I should ask that question in tricky math.
I'm sorry. It's supposed to, but not in a bad way. To get you to remember it as the same. For your range, what's your lowest point?
Negative 3.5. No, negative 2. No.
Negative 4. It's getting closer and closer to negative 4. So as you go backwards, I see these are getting closer to negative 4.
Where's the 4?
We're never actually going to touch it.
You can't touch. In the calculator, it goes.
So in the calculator, it does. Remember what it did on Desmos? It doesn't actually touch it.
Why does it touch it in the calculator?
We don't touch
There's so many zeros that it just rounds it to 4. It's so small that they're basically like, it's 4, but it's not actually.
Never once in my life felt that our answer would be something that had nothing to do with it.
That's my brain right now.
Great. The last question in this is a challenge question. It asks you to find the equation. So if, while you're practicing, you want to try that one, look at the pattern, what's happening between the y's. That would help you find your base. And then come up with an equation, see if that works, see if the points are the same. If they aren't, you may have to add in an a value. Maybe you're multiplying by something to get the points given. So then for the remainder of class, you'll be working on one of these things. These notes, the delta math on this, that's due next week. The delta math on the quadratics, that's also due next week. The delta math for today, the dividing polynomials and mixed factoring review. Past delta math, JLabs, SOL practice is due on Tuesday. Other SOL practice, if you have the math gap practice and want to do that. You have plenty of things to be working on. Work on something. Let me